let's all make sure we have our 1-1 lesson guided notes out. Where do you get that from? You come down here to 1-1, you download them. You can do them right here if you want to download, or you can open it and download, whatever. That's fine. Get those open so we can go over the practice stuff that I had built in there. I'm not going to go through this whole lesson for you because I've done that in the video. You need to do that on your own, okay? My computer died too, Alicia, but I think we're back, so that's good. I wanted to go through the review guide questions with you and the recap questions from 1-1. So these are questions from the review guide itself. So if you were to go to your course content, oh, sorry, excuse me, my coffee. If you were to go to your course content and download your review guide, you could fill these answers in right now as we go through because we're going to be going over them. So it would be a good time for you to access those. And one study guide, here we go. And fill them in so you don't have to do that on your own later. And then just review them before. Okay, so let's see how well we can remember to do this from. Yes, the study guide and the review guide are the same. So one year I named them one thing, one year I named them another. So review guide, study guide, potatoes. So go on in and get that if you don't have it, and you can answer them right on your guided notes and then just transfer it over later. All right, remember what we talked about with academic integrity. You can we can talk about these answers, but I do not want to see snips put onto your study guide to be turned in. That's not you processing the information. So you're welcome to use the answers that we come up with together, but they has to be in your own words, okay? More or less. So let's take a look at this. The review guide questions that are relevant to Unit 1, Lesson 1. All cells have the same genes. True or false? What do you think? Right here, number 1. All cells have the same genes. True or false? Okay, all the same. Okay, good. So let's go with true. But good call as long as it's the same organisms. So can you give me an example in humans of how we know that all cells have the same genes? So I guess an example would be, how do we know? Alicia, the review is in the review folder in your content. See if I can't. So if I go to your content and I go to review resources, it's in your, you can find it in your graded, you can find it in your graded assignments. Thanks, Mandy. I was grabbing the link, but you're on it. All right, so how do we know? How do we know that all cells? Good, because they have stem cells. That's right. So, for example, remember, let's see, how could we say this? John says, I'm going to put the word stem cells, which is a good start. That's obviously not the whole answer, and John knows that. He's just getting us up and running. So what do we know about stem cells? Okay, thanks, Lucas. Compare between two organs, like a liver and a heart. Yep. So, Lucas, let's build John's response and add yours in there. Stem cells make all tissues, right? So from your stem cells, you will develop specialized cells for liver and heart, but it's not like the DNA portion of that original strand gets deleted. It's still there, but it's not used. Sometimes we call it junk DNA. Here's something else we talked about. I'm just going to put the phrase crime scene, right? If you commit a crime, you never would, but if you commit a crime and you leave evidence behind, let's say you leave blood or skin or some other bodily fluid, whether it's blood or skin, they can use both of those. Why can they use both of those to identify you? If you leave like skin cells behind or blood cells behind, why would either of those work to figure out that Isaac did it, right?
Because your skin has like it's technically like your DNA in it.
Very. Hmm. Not technically, actually. Good job. Um, all of those. So crime scene evidence. So blood or skin. So I'm going to trust that you guys are going to take these kind of responses and craft your own response in there. That's right. So that's Lucas. This in pink. This is why we know that all cells in one organism have the same DNA, the same genes. Okay, good. Thank you guys. Awesome. Let's try number 2. Different genes are active in different cells. True or false? John says true. Mandy says true. Kaylee says true. Okay, here's the key word. Well, you tell me. Wow, oh, that's an E. Yeah, I did spell that right. What's the key word in this phrase? What's the most important word in this sentence that makes it true?
Different.
That's a good one. Not the one I'm looking for. I know those are the cap-locked ones. So your eye says that's a false friend. Active. That's right. Active. They're all there, but they're not all active at the same time, right? So active meaning, what example did you get from the video where I talked about your eyeballs? Oh no, she's checking to see if we watched the video. Oh no. Talked about eyeballs and why it's good that they don't produce something. If you can come up with a different example, we can toss that out too. That's okay. I didn't give you one. I didn't give you a name, Lucas. That's okay. But stomach acid, right? A hydrochloric acid. So it's good, for example, that your eyes don't produce stomach acid. That would be uncomfortable, right? Now, your eyes, your eyeball cells have the gene on their DNA that you could pull out and make stomach acid. I mean, it's there, but it doesn't happen in your eyeballs. So that's good. Other examples. Let's see. You wouldn't want your skin cell. Okay. Oh, you wouldn't need your nerve cells to make melanin. Hey, what's melanin? Anybody know? Nerve cells. Oops, not cells. Cells. Pigment stuff. Good. Thank you, Christian. Don't need melanin. That's what makes your skin all the beautiful colors we see, right? Your nerve cells inside your skin, they don't need melanin. But so an organism, even if it's a single cell or a multicellular organism, they want to be efficient. They're not going to make, hopefully, they're not going to make things that your body doesn't use or need, right? Alrighty, so the third one to talk about is number 3. Different genes are active at different times. True or false? Go on here, Kayla. Ooh, untaker. That's tricky, tricky, tricky. Different genes are active at different times. could she have given us a third true statement in a row? There's got to be some kind of statistical anomaly where you have to have one false. Not always. Sometimes I just like to mess with your head. The answer is true. The answer is true. So big example of this that you're experiencing right now in your human self. It's two examples we talked about in the video. I'm running out of things to throw at this cat. Growth, right? Okay. So, for example, one of the examples in class I gave you was the difference between fetal blood or fetal blood versus after, right? Where where the fetal blood captures more oxygen. The word was hemoglobin. And if you want to learn more about that, we can talk about that. But as a fetus inside the mom's baby pocket, they have lungs, but they're not functional. So their blood cells need to be really efficient at capturing oxygen because they have to get it from a secondary source. Where after you're done and your mom's not breathing for you, you have more access to pure oxygen in your own lungs. So you don't the hemoglobin, the red blood cell component that captures oxygen is different. But there's another one, like a more obvious example that you guys are going through right now. Sure, you're growing, but specifically some crazy things are probably happening to you guys, right? If you've noticed, you don't have to share with us, please, but if you've noticed your body's changing, you're growing hair in weird places, or your voice is changing, or all of a sudden your feet are 4 times the size they were before, et cetera, et cetera. No, good. We're good, Christian. We can all imagine it. But yeah, that is the big example, right? Right now, thankfully, you didn't have all those hormones raging through your body your whole life. It's just you're lucky enough to have them right now, because right now your body's getting ready to be able to contribute to the next generation. And now it's time to turn on some important functions, right? All right. So how are we doing about these review guide questions? Do you have any questions about the questions? Okay. Awesome sauce. These will, I promise you, show up on your test at least once or sometimes. Okay? All right. So in this page, we're going to identify the statement that's correct. So they're not all correct. And we're going to fix the statements that are incorrect. So let's just read through and figure out which of these are correct. There's only one that's true. Does anybody want to volunteer to read the first one for us? Gavin, good job. Thank you. Gavin for the win. Let's do this first one here first, and we'll decide if that's true, and then we'll move on, okay? And then you can read the next one. All right, let's do the first one.
Let's see. As cells and tissues differentiate, they produce new genes. Right or wrong?
Should I do a poll? I just recently had to learn how to do these polls successfully. I can do that. Oh, I got a true and false. Here we go. Where's the true and false? Oh, I guess it doesn't say true and false, but there you go. True and false. We're going to go with green check is true, red X, orange X.
You can say red X.
I love red X. It's just what I know. I got to make new graphics and everything. All my X's are red. Can I say how much I love having 56 students in here? This is awesome. I really appreciate all these people showing up. I know it's early. Oh, funny bone. I know it's early, but ooh, same DNA. Gavin. He's got his thinking cap on. All right, let's round this out. Let's say you got another 10 seconds. All right. Cast your ballots. All righty. We got a 50-50 split. All right. We can do this here. So our range. Okay. Oh, we just got another one. 14. All right. One more out of two more going for true. So let's discuss. Now, Gavin chimed in the chat and said, don't they have the same DNA? Right? So isn't it true that all cells have the same DNA in an organism, right? So remember a DNA, here I'm going to put a new insert a slide because that's what I like. Give me a blank one. Okay. So if DNA as a double strand looks a little bit like this, right? If we remember that these are the nucleotides, right? And they're mating in the middle. And we remember that anywhere on this strand of DNA, this is the uncoiled chromatin version, right? So this is DNA. We know it's DNA because it's double-stranded, 1, 2. Anyway, if there's a certain segment on here, like let's say it starts here and it ends here, well, it would be up here, but whatever. Like this section, I know, right, Mackenzie? I should be an artist, is a gene, right? We're all familiar that this is the gene portion. But if they all have the same strand of DNA, wouldn't it be by default true that they all have the same genes? Now, they may have different versions, right? Like this might be gene for melanin, oopsie, melanin version 2.0, right? Whereas a different organism might have a little bit lighter skin and they'd have version like 3.0. But remember we talked about this version being what did we call this? It started with an A. What is it called? Where it's a version of a gene that's different that you could pass on to your offspring and try to figure out what their phenotype would look like. It started with an A, had some L's in it. Remember?
Ali.
Lee. Yo. All right, good. Yep. Maybe the French pronounce it like that. Allele. So remember, these are just the different versions, but they all have a gene that codes for this protein, yes? So, as Gavin so rightly pointed out, since all of the cells of the same organism are going to have the same gene on it, they're not going to make new genes. They can't produce new genes. That would be like taking your DNA strand and then adding in another little snip, right? No, that's not how it happens. So you get what you get when you're baked in your mommy's baby pocket. You don't get to make new genes. You're baked appropriately. So true or false then? We decided this is what? Tell me in chat. Give me a waterfall. 3, 2, 1. Right. This is false. So we'll come back. Well, let's fix it. Since it's false, how would we make a statement like this true? As cells and tissues differentiate, they produce new genes. What would we have to change to make it true? No, but it's not the word produce, Kamayam. It's the concept that the genes are there, but you could put the word don't, right? Or, and I'll change my coloring here. You could say as cells and tissues differentiate, you could say they keep the same. Yep. Or, because we like options, not new genes, right? That's right. So they don't produce new. You could say they express different genes. How about that? Any of those would make that statement correct. That's right. So Good job on the first one. Number this one. I don't have a number on it. Gavin, do you want to read this one or do we have another volunteer? Kaylee, you want to read this one? Gavin, you can read the next one if you want.
Okay.
Sorry, that was loud. All right, go ahead, Kaylee.
All the cells have different genes, and all of the cell genes are active at the same time.
Okay, so I'm just going to have you come back here to the beginning. It said all cells have the same genes. Good job. Yep. And all of a cell's genes are active at the same time. Thank you, okay. Thank you, Kaylee. True or false? Sure. Olivia, yep. But all cells have the same genes. Let's just break it apart. Is this part true or false? Let's look at just the first part. Is this true?
First part's true, but the second part's wrong.
Okay, all of a cell's genes are active. This part is false. Do we all agree? Yes. Okay, so all of a cell's. I want you to picture something. Let's say you're not as multicellularly awesome as you are right now. Let's say you're just one organism. And well, no, that won't work. You have to be multicellular to have this conversation, Mrs. McAnally. Okay, so forget what I just said. What if every cell in your body produced all the proteins that it could possibly make at the same time? Right? Then you'd not just be making hydrochloric acid in your eyeballs, you'd also be making melanin, and you'd be making insulin, and you'd be making hormones, you'd be making testosterone in your eyeballs. You'd be, exactly, Kamaya. You'd be making a whole bunch of products and you'd be a hot mess. So, we could fix this by adding a word here. Right, Christian? Weird. Well, you wouldn't be able to see very well, would you, Jacob? So what word would we put here just to make this true? Oh, you could do that. You could change this one to different. You could add the word not. Obviously, you can't do those at the same time because then you'd be double negative and you'd be back to false again, but you get the idea. This is just ways that you can answer this question to make it true. All right, let's move on to this one. Your hair. Okay. Oh, sorry. Who was going to read this one for us? Jacob. Thank you.
Your hair is different from your kidneys because the cells that make up your hair and kidneys have different genes. True or false?
Got 1 vote, 2 votes. Should I do a poll again? I know. Sorry. I don't even know if you can see me. I get amming up here. Let's do a poll. True or false? Question. When you put a response in the poll, can you change it?
No, you cannot change it.
Oh, I liked that feature.
Once you put something in the poll, you cannot change it. Your vote's locked.
Locked. See, I liked that feature in BBC. All right, so I guess I can't be. Or the other day, I'm like, come on, guys, might want to change that, and they couldn't. All right, so put your answers in here in 5, 4, 3, 2, 1. Okay. So the majority chose true. All right, let's analyze. Your hair is different. Well, I hope your hair is different from your kidneys. That would be weird. Your hair is different from your kidneys. That part's true. Okay, we can observe that with our eyeballs. Because the cells that make up your hair and your kidneys have different genes. Have different genes. Have different genes. This part is nicht so gut. Right, this is false. This part's true, this part's false. They don't have different genes. Remember, we talked about that when every strand on the DNA is going to have the same barcode for an organism. Yeah, right? Let's think of it like that. Let's say you look at this and there's a different gene for something else here and a different gene for something else here. And you end up with a barcode for an organism, right? That's the same. It's why it's like your barcode looks like this, and then you run it. I don't know what a barcode looks like clearly, but you get the idea. So they don't have different genes. So how can we fix this? I've got one person timing in chat. Not different genes, just expressed differently. Okay. So we could say have genes expressed differently. That's good grammar. Don't tell your ELA teacher. Okay, something to that effect. Any questions on why that's not correct? I know. Now somebody asked to read the last one. Did you want to read the last one? I don't remember. Coming back up. Somebody said, I want to read the last one. Scrolling.
Olivia said she did.
Oh, thank you. Thank you, Olivia. My bad. Good. All right. Olivia. And Alicia, I know you want to read. We got more questions on the next presentation. You can read then, okay?
All cells have the same genes, but different genes are active in different cells.
So, I hate to be a spoiler, Olivia, but you're the only one that we haven't determined is already false. So, Olivia for the win! Yay! Okay, so this one is true and is very well worded. All cells, the same genes, different genes are active in different cells. So basically, here's the learning targets, right? Make sure if you're not sitting at A or B here, you're going to want to come to the session on Friday. So if you're sitting here at C, I'm going to see you tomorrow after Beacon Buddies. Tomorrow, okay?